Alright, you're alive. Hi there, Snow Golem. Uh, these aren't classes, but I hope I will be able to help you in some ways, I guess. I don't know, maybe you can benefit from this, hopefully. So, I believe the sound is alright. Let's just check that beforehand. Yeah. Okay, so let's see what we've done so far. Uh, doesn't look like a crowd. Okay. Uh, anyways, let's begin. Let's just summarize what we've done so far. So we started writing a writing a simple example, which via which we would go about redesigning the interface and fixing some stuff that I believe are design flaws in the code. So I started by providing this IYP render interface, and then we designed this render aware unique footer to manage our object lifetimes, and then we started providing some basic interfaces for adding shaders, samplers, whatever, and then we went to actually draw something, and that was the graphics command, and that is where we are left off yesterday. So I'm just trying at the moment to draw a single skybox. That is what I'm trying to do at the moment. But after that, I don't think drawing anything else would be a problem. However, I would like to redesign this again. There are some design flaws already in the code in my new interface, so that is also something that I would be doing. Anyways, uh, so this is where we left off yesterday. Let me just run this code. Okay, so we're just clearing the screen. However, our managed lifetime, which is here. So we're managing lifetime via RAII, uh, which just is resource uh, acquisition is initialization. So that is the model we're managing our lifetime. So what happens there is that my swap chain here, I'm gonna first fix that part, then we'll continue on adding new features. So let me just give a quick review on what the problem is. Okay, I'm here. Uh, so we have this swap chain here. Let's collapse everything we don't need. And here, this is our swap chain. So we have this swap chain here, which has a swap chain pointer, which is a managed swap chain, and then we have this semaphore for it, and one image index. We have three images in one swap chain, so the length of the chain is 3, and we just keep iterating through those three images, and we draw one at a time. The problem I believe is that we're destroying the swap chain while the renderer is actually using it, while the device is actually using it. So the proper way would be to actually wait on this semaphore, and then do this. And I believe I would be doing that. I'm not going to do that at the moment. I need further understanding of what our threading system is, the thread safety is handled, because we have a bunch of fences and semaphores here as well. So I don't know. The other issue is, should the lifetime of the semaphore exceed the lifetime of the swap chain? Those are questions that I do not have the answers for at the moment. So let's just finish our bind render targets. So that is our interface for bind render targets. There's an optional depth render target, which is depth stencil render target to be more correct. And so let's just call it depth for now. And there's render target load actions, a bunch of other render targets. Those are our colors probably. And a render target is as we defined it here. A render target load action is a render target and the clear value. So the clear value just says how to actually clear the render target at load. So if a clear value is available, we would do the clear. Otherwise, we would just bind the render target. And yeah, that's what we're trying to do. However, the interface that is provided to us by the Forge is a bit different, and we would need to actually do some kind of remapping here. So let's do that remapping. So one thing that we need to provide this function with is a bunch of pre-render targets. So a bunch of pointers to render targets. So that is going to be provided by this array here. Render targets. So that's an array of render target pointers, and then this is going to be our render targets. And then we would need to provide just as many. Also, we have the maximum render target attachments. Here we're going to use that. That is why I'm using stud array here. And what else do we need to provide this? We would need to provide stud u32s of array slices. Array slices. And then we would provide the same, but this time MIP slices. That is the number of arrays in one texture, or the number of MIP maps in one texture, in one render targets to be more correct. And then that would be it. This should be pretty straightforward. Okay, let's just fill this. Render targets. render target link action. And in that render target, I believe we have buffer. Oh no? We have render target, yeah. Okay, that is partly it. And then we would have this as well. These slices should be filled here. Nib count. Array count. Let's rename this. Maybe length and nib count. Let's change that as well. Array length nib count. Alright. So array length, and that is count. Alright, that is that. I'm hoping that is going to work well. Let's see what we've provided so far. Number of render targets. That is going to be our render target actions dot size. And then we would be providing the render targets themselves. That would be render targets dot data. That just happened there. Dot data. And then we would provide depth stencil render target. That would be an optional, because our depth is an optional. Let's rename this to depth stencil to be more accurate. It's depth stencil. Alright, let's rename that. Okay, so render targets, data, and we would be providing a depth render target if available. So that would be if available, else null footer, and we would do it yeah. Maybe I should do this twice, or maybe I should provide variables. Let's do this. Depth render target const auto depth Mhm. It's going to be either this or, yeah, let's simplify this. So I'm just handling the optionality of the diff buffer here. I'm just saying if you have diff stencil render target load action, the diff render target is going to be that. Otherwise, just construct one. And then I would use this dot render target. Okay, and then I guess the next parameter is load actions, which we're providing. Oops, not anymore. Okay, and the other parameter is going to be color array slices, which is going to be array length dot data. And then we would have meep counts dot data. Allah dot data, and then what else? Dip array slice, which is going to be array length. We do, and then meep count. Okay, I'm happy with that. I'm gonna reorder these. And I'm going to get some narrowing warnings here, which is because these are Uint32s. These are size T's, which is a proper type actually. So static cast in here to Uint32. Alright, sorry about that. I guess we're back on. Uh, Alright, we're back on. Sorry about that. That was such a misfortune there. Alright, hopefully everything is going to be fine. And yeah, let's get back to it. Let me just check. Yeah, we're fine. So yeah, we just finished our bind render targets, and I believe we're just fine. Of course, I'm going to do some static casts here. And yeah, we're going to cast these two Uint32s. Okay, let's go ahead and compile this. I'm pretty sure we're not using these functions, so yeah, let's start using them. Let's start using them as they're supposed to be used. So here is our draw function. We're going to acquire the graphics command. Let's see what it does. Acquires calls acquire. Alright. And then after that we have, so this is the routine we're going to go. We're going to use the routine that was used in the example. Submit now. Right, yeah. So yeah, barriers, command, resource barriers. We don't have this interface. We should provide this interface here. That will provide resource barriers. Yeah, that is something we should do. Also begin command. Do we have begin command or do we not? I think I should call the begin command inside the acquire. Let's see. Because that's pretty trivial, right? You should begin the command at, yeah, we are beginning the command here, and then when we submit, we end the command. Okay, that is fine. Let's see what interfaces we have so far. We have bind vertex buffer, we have draw, we have bind descriptor set, bind pipeline, bind set viewport. This is set Caesar. Caesar, and then we have set viewport, bind render target acquire, and yeah, we're missing the bind. We're missing the barriers. We're missing resource barriers. Okay, let's do this then. Add resource barriers. Did I spell that correctly? Nope, I'm missing an R here. And that's that. Yeah, that is our bind resource barriers. And what is a resource barrier? We have multiple types of barriers. Some are buffer barriers, render target barriers, and yeah, that seems to be it. Uh, yeah, I'm quiet because I'm thinking about how to actually implement this. P render target, P buffer, depth buffer. So the reason I'm thinking about this is because it says buffer barrier. However, this is just, oh yeah, okay, that is correct. So we would also have to wrap this buffer barrier type. Because our user doesn't know about buffers or render targets, it just knows a handle. Maybe we're better off like providing the pointer itself rather than the handle as the handle. That would make us type safe and also would help us to avoid these kind of messes. We already have some mess around here. Let's see. So we have a bunch of to-dos here that is caused by that. Let's check those. Yeah, like this cast to shader pointer and many other likewise casts here. So if we actually were to provide pointers rather than, or maybe we would just provide handle types. What about that? I think I like that. I do think that I like that. Yeah, let's do that. That is going to be a lot of usings here, using declarations. Shader, handle type. Let's avoid those. Let's avoid those for now. Let's just provide shader pointer. Sampler pointer. Root signature pointer. Descriptor set pointer. Render target pointer. And then pipeline pointer. And let's make all of our handles type safe then. I'm going to provide a using declaration for each of these later on, because I don't want to leak that this is a pointer here. I want the user just to think that this is a handle. I don't care about what the actual type is. This is just a handle. I'm given a handle and I'm going to get back. So yeah, that is what I would like to do. There goes those reinterpret casts. We're actually making the code smaller. Sampler, come on. No, no, no. Why am I just pressing the exact wrong button every time? Sampler pointer. And that is going to be sampler pointer as well. This is going to be root signature pointer. This is kind of funny, like how we are actually stuck at the 99 percentile of our progress. Like we are so close to just getting a render done, but a lot of a lot of features, a lot of new issues are just creeping on us. Using shader handle. Yeah, I'm going to use using declarations here. Just right now. Not going to postpone that for later. these would be also better done if they were done here. So I'm going to become public for a moment, and then everything is going to be back to private in here. That is just so that these could actually benefit from these. This is probably not really that fun to watch, me copy pasting everything. But that is just the work I should do right now. Okay, let's go for the pipeline here. Add pipeline. That is going there. Removing the intercasts. That is to be removed as well. This is to be removed. Same with render target. That is going there. Intercast is removed. We should be fine. My worry at the moment is that the EASTL map wouldn't support pointers as key. Then we would need to write our own. We would need to write our own hash function for that, for pointers. That wouldn't be much work, but still it's gonna be some work. Also, this just doesn't have much. This change that I'm doing at the moment will not have much effect. At sampler, is that void? Is that sampler handle? Is that going to propagate so much code really? So much changes really? It's just going to be simple. Sampler handle here as well. And we should be fine, I guess. That's that. That's all of it. Is it? Shader handle, blah blah. That is great. Okay, I believe this code will compile. Just like so. Like with no changes on the user code. But seemingly not. Shader handle, what is that? That's shader. What is it saying? Oh yeah. There's going to be some minor changes here. Using rend. Okay, we need to using decoration here. Render type should be this. Not that, but this. And we're going to use that. Shader handle and root signature handle. Okay, I guess that is fine. Which part of the code is this? Alright, that is correct. What is the reference? Root signature header. What does this say? Cannot convert okay to UNPDR. Which one is UNT pointer here? Okay, descriptor set handle. Ah, we've got it to compile. Okay, that's that. Of course, we are still crashing because we're not safe releasing our swap chain. That should be easy to fix later on. Anyways, that is the code right there. So now the reason we went about doing that was let me just check this. C++20 span. So yeah, it does have data and size. That is what we're using. Alright, I would assume that someone using C++20 and my interface would provide me with the spans here. Spans on literally everything, everywhere that I'm taking a container. Okay, let's add this last, add resource barriers. So you would have a texture resource barrier container. Then let's just check that. Let's check what the interface actually wants. Buffer barriers, texture barriers, and render type barriers. I'm gonna rename that. You don't want that is there. And we are doing type. It's important to keep consistency in your code. That makes understanding the code later way easier. So we would have buffer resource barrier container type, and then texture resource barrier container type, and one more for render target. Alright, let me just check render target. Let me make sure that the order of these are the same with the Forge Engines order. Buffer, texture, and render target. That is correct. Okay. And then we would like to simply call this. I would like to also remove this container. It doesn't have to be a container. Huh. That is where our command goes. This is size, and then would be data. Let's move on. Then would be the next parameter. Ah. Texture resource barriers. Alright, and then the last one, render target resource barriers. And there goes that. And our last touch would be command pointer.get. Okay, I'm fine with that. Collapse that. Let's actually use it now, shall we? So we're going to start actually drawing this thing. Update these are resource manager, resource loader calls. I'm gonna copy this one and call it. We haven't abstracted out the resource loader yet, so I'm just using the old code here. And I also believe that is going to get there. That is because of some synchronization they're doing here. They're being smart. Or rather, they're being really stupid. So let's see if I'm actually providing the interface for image number. I am not. This one is using it. Let's see. So what this code is doing here is to update my uniform buffers. And I wanted to update, however we have a little problem here. And that is that we do not have this at hand. Let's do this. Interpret cast. That is not a safe cast there. That is not a nice cast either. That is just a bad cast being used. However, this is still our problem. I don't want to provide an interface for this to actually get that. Maybe this will do it. What about that? Sorry about that. I guess sometimes you have to snooze life, sneeze life. Alright, I'm going to include utility for that. And that would be it. Just make pair there, we return a pair, and we use that pair here. Let's reverse the order. First is going to be my index, and that is going to be my uh, graphics command. Let's reverse the order. I'm doing that to go with the key value uh, pattern. So you could look at this as a key value, which it actually is. Okay, I'm happy with that. Okay, alright, after doing just that, I am I am going to I'm gonna do some stuff with this. So firstly, we would want to what would we want to do? We would want to set some resource barriers. And that would be like add resource barriers. And we only are adding a render target resource barriers as I see here. So ESTL array of render target area. Alright. Number is going to be 2. Render target barriers. I'm going to put this in scope so that we wouldn't actually need to have this scope so to have this variable leave for so long. And I'm just going to provide an ESTL area of size 0 for these. So first one was texture barrier. So just if you didn't know this could actually work, it could, it does. ESTL area. Next one is going to be okay. Next one should have been buffer textures, not this one. This should have been buffer barrier. And of course, the last one is our render targets. And we need to actually then you would need to actually then add pipeline. No, where do we add render target? Yeah, you would need this div render target descriptor handle. Not descriptor handle. Where is this used? Over. So I'm going to make this a member, and I would also need to add some. I would need to add an extra interface to my swap chain. Okay, we are 57 minutes in already. We are pretty darn close to end here. Let's make that like so. Let's copy paste this there, and yeah, now we just need this view render target. I know we're going to need some redesigns, some not many. So I'm planning to actually design this in iterations. So each iteration we're just getting closer to the perfect design. Require command is going to give us index, and then I'm going to provide this. Get swap chain sample quality, no. Swap chain format, no. I need a getter here, and that is going to be render target handle. Get swap chain render target, and that is going to get an index. All right, and what that would return would be this. Swap chain footer, okay, and that would be index. All right, you would simply use that here. Render get swap chain render target. Yeah, what is the problem here now? Alright, let's see what the problem is. Too many initializer values. No instance of template, blah blah. Let me check that. What is the problem there? First one is buffer, second is texture, and the third one is render target, resource barriers. So, what is the problem? No instance of template function template, blah blah. Why would it not match the argument? Why would it not match the argument list? Like all of my parameters are template type. Why would they not match? That is weird. Hmm. That is weird. That should just match. I don't get it. So there is something happening here. And that is that I am not properly closing this. Okay, that was happening there, but this is happening here. Let's see, let's submit. Okay, I'm gonna put the submit. Man, what is wrong there? Qualifier dropped. Of course. Okay, and that works. Yeah, everything works now. Alright. I I guess I'm happy with that. Can I convert from right. So their make pair is not doing that. Maybe tie? Let's see this one. So the problem here is that this is a value and I want to return a reference here. And this make pair is not working here, so I'm trying to get something that would actually. So we have tie here, to tie. Crazy tuple of L value. I want make pair. I want pair equivalent of tie. Okay, Let's just ignore that. Let's just construct this simply. Cannot convert argument tree from const t pointer to barriers pointer. Buffer barrier pointer. Argument tree. Why would the argument tree be buffer barrier? Argument tree. Texture data. Okay, yeah. We need to add some const here. But should these actually be const? I believe these should be const. So should this. And then I would need to also go to the iRenderer and fix the signature there. And yes, I would need to static cast these. Like these. No object for granted party. Please don't errors. Yeah, I would need some static cast here to unit 32. I don't know what the obsession with Unit 32 was when they were coding this, but they've just used Unit 32s everywhere. Hooray! Code compiles and works. So, you just added resource barriers. Didn't do much. Have your 11 minutes overtime already. Let's see what else we should do here. This is just binary render targets. We could simply do that. Let's be quick and do that. After render, we're just going to use command graphics command right now. By render targets. So first one is going to be our stud area of render targets, render target load action. That is going to be render type render target load action. I believe that is public. Let's see if that is public. But it should be. It isn't. Yeah, it is. It's public. Yes, it does. It does have such member. Why would you say that? Why would you say that? This is the member here. Oh, oops, oopsie doo. That is that part. Let's close this. Just kind of move those here. And then I'm gonna move the public on top of that. Alright. And one. We're going to give it only one load action. And then we're going to construct a load action here. And what would the load action have? It would be load action. Also, this name can conflict. I would need to change these names. That I'm going to use. Only one? Was this not used? Oh yeah, it's not used. Alright, that is not good. That was a huge mistake right there. Okay, that I'm happy with. We are almost 20 minutes over time. Let's just finish this part. need to go wrong here. Something went terribly wrong here. No. Okay. Then did I remove that? So render target load action is going to be constructed. Likewise, render type visor error there still. Maybe we have an error. Okay, we don't. It compiles. We are fine, and we definitely survived that rename. Okay, so I'm going to just fill this with render target descriptor, which is going to be filled like so. This is going to be uh, let's see. It's going to be filled with that a vec4. So let's color this red for now. And I'm going to do this to get the render target. So we have a problem here, and that is this. This should be a render target handle. So that actually means we're going to put these using declarations above this one here. So I guess this is gonna be such a headache for you to follow. I don't know, maybe. STL. Okay. And what is this? Noticeable conversion from render target load action to load action typing exists. No matching overload. Render target. basic blah blah. Find random targets first gets a constant ER container and then an optional. Okay, yeah, we should provide the optional here. That is going to be render target load action. And what would we put in it? It would be our depth handle and our clear value. Alright, let's make sure that these are floating points. Floating point and uint32. I believe that is correct. But most of the conversion from function from okay from blah blah to uint32. What do you mean? Most of the conversion from function. Most of the conversion function from clear value to size t exists. Why would you want a size t here? That is weird. Which one is this for? Alright, I guess I get what the problem is here. Let's see if this works. Let's do this. Let's forget about the depth buffer at the moment. That is going to be an empty ESTL optional. I could not figure out what the error message was trying to tell me. That would be STL-get, not STUD-get. Then if get isn't optional, then what is? It's telling me that there's no member called get. And what do we have? Really? Does optional not have a get? Huh. That is just funny. I thought it did, to be honest. Right, that should be STL as well. And what is RGBA a member of it? Let's see what this Vec4 thingy is. Can we actually access RGBA on this? Yeah, I get Z, so I should use the getters here. What is this saying? Can I convert argument 1 from load action descriptor pointer? Sorry. That compiled, and we have a bug somewhere. Okay, the bug is easy to fix. This shouldn't be accessed here. This should be. This is just some copy paste bugs here. We have a bunch here. Alright, we cleared our screen right. That is progress. That is indeed progress. Alright, I guess tomorrow we will be able to actually draw our skybox. And we are already 35 minutes over time. So, yeah, I'm gonna leave the rest for tomorrow. Thank you for watching. See you next time.